Hi guys, and welcome back to 3 Layers Deep. Thank you so much for tuning in. So like I promised from the last video, this video I'm going to be discussing inflammation and how inflammation correlates with the free radicals and causes aging. Now in my last video I did speak about free radicals and how that affects how our cells age, how our skin ages. All right. Now, if you're probably wondering, like, well, what do you mean? Like, how does inflammation cause aging? Remember, we're not talking about what you can physically see. All right. You're probably envisioning like redness, swelling, irritation. That's what kind of comes to mind when you think of inflammation. Well, the kind of inflammation that I'm speaking about is actually called subclinical inflammation. And it is caused in the cellular level, all right? And it's obviously invisible to the naked eye. Now, what happens is when, before I even start explaining the whole inflammation and aging thing, I have to give you kind of like a visual. I need you to envision something with me. Now, it's funny because like not a few, but here and there, I may get someone that places comments, or puts a comment in my video or whatever, and, saying, hey, you should have had like a drawing board for that, or you should have, made a picture of what you just said, because it's kind of hard to, to picture in your mind. Well, unfortunately, I'm sorry, I can't draw for the life of me, and it would be kind of uncomfortable to sit here and try to explain while I'm like drawing something. So what I can do, I can kind of give you an analogy or an example. All right, so before I concur, I'm going to ask you to envision a raw egg in the shell and everything, just a raw egg. All right, I need you to envision it so that as I explain this process, you'll be able to have a better understanding of how this is taking place. Okay, ready? You ready? You have the egg in your mind? All right, let's begin. Okay, now think of the shell itself, the white hard shell. Think of that as being the plasma cell membrane. Got it? Plasma cell membrane. That is actually what encases the cell. Okay? Then envision the white of the raw egg, the jelly part, as the protoplasm, and that's where like all the like mineral salts, the water supply, the carbohydrates, proteins, the fats, that's where all that is being housed. It's actually what gives nourishment to the nucleus. And the nucleus would be, can you take a guess what the nucleus would be? I think you're pretty smart. You can figure that one out, right? All right, you can't? All right, I understand. No, sir, I'm just joking. But the yolk, the yellow yolk, would be the nucleus. Now, the nucleus is very important because that is where the DNA is housed, as well as the mitochondria. And if you don't know what a mitochondria is, it's like the little furnace of your cell, and that the mitochondria converts the fats into energy. Okay, so that's what helps for the reproduction and the metabolism of your cells. Healthy reproduction, healthy metabolism. If your cells are functioning the way they should, at the speed that they should, then you pretty much have healthy cells, which in turn gives you a healthy body, because it's not just our skin that's made up of cells. Our entire body from the inside out is made up of cells. Okay, so now that you have a kind of an understanding of that, now I'm going to start explaining what inflammation does. Okay, so when a free radical damages a cell, all right, free radicals are attracted to where the most molecules are located, all right? And when it comes to the cell, it would be the cell plasma membrane, or the fat layer, all right? And the fat layer is it's rich in molecules. And remember that the free radicals, they're in search of that missing electron, that they're seeking to complete their outer orbit. So they're kind of unbalanced, they're unstable, correct? Okay, so what happens is the free radical goes ahead and seeks their little electrons, and it starts to damage the cell plasma membrane, which I just explained is richly packed with molecules. And where there's molecules, there's electrons, right? Right. Okay, so what happens is the free radicals start attacking the cell plasma membrane, right? That's the outside casing of, gosh, I have like an itch. All right, that's the outside casing of the cell, all right? So they start attacking the cell plasma membrane, all right? In the meantime, what happens is they damage the outer portion of the cell. The free radicals produce an enzyme, a special enzyme that breaks down the fats in the cell plasma membrane. Now, during this fat breakdown process, I believe I explained in the last video, it produces or activates another enzyme, which is called arachidonic acid. And arachidonic acid is like a precursor molecule or molecule that causes inflammation, that actually is oxidized. What the heck is oxidated? It's oxidized into other pro-inflammatory chemicals, all right? So what happens is throughout this entire process, just envision the cell plasma membrane, all right? Envision it being attacked, right, by these free radicals. It's forming these chemicals, and what's happening is when the cell plasma membrane is being damaged, and that membrane is what actually lets nutrients in and wastes and salts out. Now, when it's damaged, it can no longer do that. It can no longer perform the job that is originally supposed to do, all right, which is protect, keeping, try to bring in nutrients and expelling salts and wastes, all right? So what happens is when the free radicals damage that cell membrane, it causes these inflammatory chemicals, and what happens is like the wastes and salts can no longer be expelled out, and nutrients can no longer be brought in. All right. So what happens is the wastes and salts begin to take like potassium. All right, potassium, which is like a waste or salt. Not a waste or salt, it's a waste. Whatever, you know what I mean. It's in there. Anyway, so what happens is these wastes and salts begin to take an increasing amount of space. It almost makes the cell plasma membrane swell up, okay? So that's how you can kind of envision the inflammation taking place, all right? So it starts to take up an increasing amount of space within the cell plasma membrane, and in the process, or as it's doing this, is actually pushing out the cell's water supply. So as it pushes out the cell's water supply, the cell is starting to become dehydrated, all right? And something that is dehydrated begins to age. Think about your skin. Like your skin, when your skin is dehydrated, it kind of looks crinkly. It has almost like, especially like around the nose area and like your forehead area, it almost like you could just like move your the skin on your nose like that, and like your forehead like that, and it almost has like it looks like an extra layer, like a very thin extra layer, almost like, that little thin layer that an onion has, and it looks kind of crinkly, and then when you remove that little extra like clear layer, that's what the nice fresh layer of onion is. Okay, so that obviously dehydration can age the skin. So that's exactly what's happening, but at the cellular level, all right? So that is how inflammation takes place, and that's what happens. That's how it ages the cell, because it is pushing out the cell's water supply. It's no longer letting the wastes and salts out, and it is no longer letting the cell taking any nutrients, and that's just in the cell plasma membrane. Now, when this inflammation starts to push its way, or these inflammatory chemicals push their way into the interior part of the cell, into the jelly-like part of the cell, which is the raw part, or the white raw part of the egg white. I cannot speak. I'm gonna have to edit some of this video because I'm all over the place. I feel like I'm like very repetitive. I'm sorry, I apologize. Anyway, so once it starts to make its way inside that the jelly part, which is the protoplasm, that's where like all the nutrients and stuff are, it starts to activate other proteins, all right? And that's where the transcription factor NFKB is activated, and then that causes more inflammation, and then inflammation leads to another activation of more free radicals, and then the cycle just continues. The more inflammation, the more free radicals, the more free radicals, the more inflammation, and that starts to literally deteriorate the cell from the inside out. Then from there on, it takes it starts making its way into the nucleus, and once it gets into the nucleus, it starts to reproduce faulty cells, all right? And like a lot of like age-related diseases, like Alzheimer's disease, and even like arthritis, anything that is it contains inflammation when it comes to age-related diseases, or even cancer, all that goes back to free radical damage that causes the inflammation. So it's not just the skin that gets affected, it's your entire body. So you not only learned a little bit about skin itself and inflammation, but now you have a better understanding of how it does age, and you got a little bit of schooling on how free radicals are the culprits for age-related diseases because they cause inflammation. So guys, I know that was pretty extensive. That's like how long? 13 minutes long. I'm sorry. I'll try to make shorter videos. I don't know, it's just like so much information in in my videos that I don't want to cut pieces out, but I know I'm gonna have to write in areas that I feel kind of repetitive. So if you see edited parts, it's because I was pretty repetitive in certain things. So I hope you guys enjoyed. I'm sorry it was like ridiculously long, and I will talk to you guys in my next video. God bless you. Bye.